Okay, let's start with chapter 4. And this chapter is on sensation and perception. So, of course, we're going to talk about the 5 various senses in this chapter, right? Vision, hearing, taste, smell, and touch. But the second half of this is the perception of those sensations. We are bombarded with billions of sensations throughout the day, stimuli that hit our senses. We probably only notice a very small portion of those billions of stimuli that hit our senses. When we become aware of them, that is the perception aspect of that. So there are 4 modules, excuse me, I almost said 3. There are 4 modules in this chapter, 10, 11, 12, and 13. And the first module I want to go over is module 10, and this is sensing the world around us. And there are 2 questions we are going to answer in this module. The first one is, what is a sensation? And how do psychologists study those sensations? And then the second question is, what is the relationship between a physical stimulus and the kinds of sensory responses that result from it? So physical stimuli are, something hitting your eyes, something hitting your skin for your sense of touch, something entering your mouth for your sense of taste, so on and so forth. So we're going to talk about the physical stimuli and then the relationship of those physical stimuli with the kinds of sensory responses that result from it. So let's start out just with basic definitions of what a sensation is, what a perception is, what a stimulus is, and what we mean by this area called psychophysics. So psychophysics, as you're going to find out here in just a minute, is a combination between psychology and physics. So first off, basic definition for sensation is that it is the activation of the sense organs by a source of physical energy. So that would be taste, smell, touch, hearing, and vision. So there is some sort of physical energy out there in the environment, and that stimulus will hit your senses. Perception then comes along after that. And perception is the sorting out or interpretation, analysis, and integration of that stimulus by the sense organs and the brain. So some stimulus hits one of your sense organs, that information travels to the right sensory cortex in your brain figures out what the message is, and then travels back down so that you know what to do, so that you are aware of what that stimulus is. When we are talking about stimulus in and of itself, a stimuli is a type of energy that produces a response in a sense organ. And then psychophysics is this area in psychology where we study the relationship between the actual physical aspects of a stimulus and then your psychological experience of that stimulus. So the physics part is the stimuli hitting your sense organs. The psychology part is you being aware of it and knowing what it is. The first thing that we want to talk about is an absolute threshold, detecting what's out there. What we mean by an absolute threshold is that it is the lowest intensity of a stimulus that an organism can detect, usually at least 50% of the time. The absolute minimum that it would take in order for you to detect it at least 50% of the time. There are lots of stimuli that we do not detect. But the absolute threshold would be the bare minimum that it would take to detect, at least 50% of the time. So how psychophysicists define this is that noise is a background stimulation that interferes with the perception of other stimuli. As you are sitting there right now listening to my lecture, there are lots of noises going on around you that you are not even aware of. But if you stay quiet for just a few seconds, you may have picked up just right now on various other sounds that you would not have noticed because you're listening to my voice coming through in this lecture. So let's think about this. Let's think about how sensitive you actually are, right? So we're talking about the absolute thresholds, the bare minimum that it would take for you to detect something. So for, your test awareness, which of the following are true and which are false for you? And we are also individualized that it may be completely different for someone else living in your home or one of your relatives or one of your friends. So let's think first about vision. On a clear, dark night, can you see a candle flame from a distance of 30 miles? I'm probably going to say most of us would say false. However, this is the absolute threshold that it would take for you to detect a vision. But you have to remember this would be in perfect circumstances. No other light outside. You are out in the middle of completely nowhere. Would you be able to detect a candle flame from 30 miles? Let's go on to your sense of smell. Would you be able to detect a single drop of perfume in a 3-room apartment? Again, probably false for most of us. However, under perfect conditions, this would be your absolute threshold for smell. The problem with most of us, though, is that we cover up our sense of smell. We wear body lotion, we have candles burning, we have perfume, we have body wash, we have deodorant, we're cooking foods, right? But in an absolute perfect condition, the absolute threshold for smell is that you could smell a single drop of perfume in a 3-room apartment. Your sense of hearing. Under quiet conditions, could you hear the ticking of a watch from 20 feet away? Now think about the size of a watch. And would you be able to hear that? Even 20 feet away is quite a distance. And probably most of us would not be able to because there are so many other sounds going on in our environment. But if we were in a soundproof cubicle or a soundproof room, this would be our absolute threshold for sound. For taste, would you be able to detect 2 tablespoons of sugar dissolved in 2 gallons of water? So think about the size of a gallon of milk. Think about 2 gallons of milk. You're going to fill up those milk jugs with water. You're going to empty both of those into something, into a container, and then put 2 tablespoons of sugar. Would you be able to detect that sugar sweetness? I don't know. This one seems a little bit better than the other ones that we've talked about. However, it is the absolute threshold for taste. All right, so we just talked about absolute thresholds. Now I want to discuss what is called a difference threshold. And this is whether or not you notice a difference between two different stimuli. So the difference threshold is the smallest level of added or reduced stimulation that is needed for you to see that there's a difference in those stimuli. Sometimes the difference threshold is called the just noticeable difference, or the JND. If you have two weights in your hands, right? And both of them are 10-pound weights. If I just put a 1/10 weight into one of the hands, would you be able to notice that it's a little bit heavier? Possibly not. 1 pound? I don't know. Maybe 1.5 pounds. Now you notice that one hand is heavier than the other. That 1.5 pounds would be your JND. So it's the smallest detection that is needed for you to notice that there is a difference between two stimuli. Again, I used your sense of touch. You could use your sense of hearing, your sense of smell, your sense of taste, your sense of vision. We have, not only in psychology, but in physics also, what is called Weber's law. It's actually pronounced Weber's law, like a V, because it is German. But I'll pronounce it Weber's law just so you don't get too confused. It is a basic law of psychophysics. Remember, psychophysics is the physical sensation and your detection of it. Your detection is the psychology part. So Weber's law is a basic law of psychophysics that states the just notable difference is a constant proportion to the intensity of an initial stimulus, rather than the constant amount. I want to finish up Module 10 talking about sensory adaptation. Actually, I think there's one more slide after this. I lied. So, sensory adaptation, turning down our responses. So when you adapt to something, you get used to it, right? That is what adaptation means. It's an adjustment in sensory capacity after you have this prolonged exposure to that stimulus. So think about in the summer, whenever you go into the ocean or you get into the pool, the water is really cold at first, but after you stay in the water a little bit, it doesn't seem as cold anymore. The same thing if you get into a hot tub, or if you're eating really hot soup, you take a little wee sip and then it doesn't get so hot the more you sip it. This happens with me with coffee in the morning. I am really addicted to coffee, and I am not too patient to let it cool off in order to drink it. So almost every morning I will take a little sip of coffee and burn my tongue, and then I'll take another little sip of coffee, burn my tongue again. By about the 5th or 6th sip of coffee, it's not as hot anymore. I have adapted to that temperature. The decline that we see in sensitivity to sensory stimuli is due to the inability of your nerve receptors to fire off messages to the brain indefinitely. It is not going to keep firing and firing and firing. It may at first, but eventually it is going to stop firing those nerve messages to your brain. That is what we see when we talk about sensory adaptation. Your sensory nerve receptor cells are the most responsive to changes in stimulation. Constant stimulation is not effective in producing a sustained reaction because you're going to adapt to it, right? So if you have this constant noise that's going on, you will eventually adapt to that noise. So it's not going to be effective if you're trying to determine the difference over time in this sound or the difference over time in this taste.